I want you to imagine you're in a car driving down the road at 75 miles an hour. Okay, maybe Interstate 64 from Shelbyville to Louisville. Are you there? Are you picturing it? Okay. And you're driving along, and maybe you're slouching back in your chair because you're not driving, and you see a car go by, and it's doing like 90 miles an hour. From your perspective, all you can see is maybe bits of sky and the car that's traveling with you at 75 miles an hour. The car went by at 90. How fast did it look like the car went by? Not as fast. What do you mean?
Because you're driving a little bit.
Because you're going 75.
Yeah.
So when I'm telling that story, what you should be thinking of is what's the difference in speed? 15. Very good.
So it's only going to look a little
Because 90 minus 75 is 15. So that, from your perspective, everything in your life is going with you. Because the sky maybe doesn't have any distinguishing features, or the clouds are way off, so it doesn't look like stuff's whirring by you, right? It doesn't feel like you're going 75. It feels like you're just stationary, other than the bounces in the pavement or whatever. You see a car going by, it's going 90, but you are going 75. So it looks like it's going 15 to you. Does that make sense? That is what's meant by motion is relative. The motion of that car that went by you is relative to your motion. Okay? Here's another one. You're going 55 miles an hour north up towards Jeffersontown on Highway 55. Convenient, right? A car is coming the opposite way towards you at the same speed. What is the closing speed? Relative to each other, right? How fast is that car coming at you? You're going 55 this way. It's coming 55 this way. What is the closing speed?
0.
55.
How much distance are they coming over time towards each other? They're going 55. You're going 55. 110. The closing speed, you're approaching each other at 110 miles an hour because you're adding those speeds together. Does that make sense? If you're going the same direction, you want to know the difference between the speeds. If you're going towards something, you're going to add the speeds together. That's how fast you're closing. Yes?
When you drive and say you're both going like 55, are you guys hitting like at 110?
The impact speed is the equivalent of hitting a concrete wall at 110 miles an hour. That's nuts, right? Okay, cool. So that gives you an idea. I'm going to do one more for motion is relative. I'm going to draw the most beautiful circle you've ever seen anyone draw. Yes?
What about if you slam on your brakes before you hit them? Like you're going
Well, then you'd be reducing speed. So depending on how much speed you bled off by hitting the brakes, you'd still add that speed at impact with their speed at impact. Make sense? Okay. All right, here we go. I'm going to make my attempt. That's not bad. Not bad. Not bad. You've probably seen better. Okay. All right. Shh. In your notes, maybe take like a half a sheet of paper or so, and we're going to call this Earth. We're going to say this is a representation of our planet. Okay? And then we're going to draw a like partially diagonal line through the center. Why did I draw that? What is that?
The equator.
Nope. What? It's the what? Axis, yes.
Okay, aren't those the same?
Because the Earth is slightly tilted on its axis, right?
What the heck?
All right. So north to south, the point around which the line that around which the Earth rotates, because the Earth does rotate, does it not?
It's flat.
Okay.
Earth is not flat.
At some spots, I mean, this classroom floor seems pretty flat. So the point, or the line around which the Earth rotates is the axis. We're starting to talk a little bit too much again. And then, yes, somebody mentioned the equator. That is the imaginary east to west line at the center, halfway between far north and far south, right? Okay. Equator.
Right here.
Does anyone know the circumference of the Earth, the distance around the Earth at the equator? Does anybody know that by chance? No? All right, I'll give it to you. 24,000 miles. give or take a few.
So if you go all around the world, it's 24,000.
Yeah, so now there's oceans and stuff and mountains in the way and whatnot. But if there was a road paved all the way around, it'd be 24,000-mile road. Okay. All right. Now, I'm going to draw a couple of stick figures because that is the extent of my artistic ability. And I'm going to put somebody right here at the North Pole. And I'm going to put somebody else right here at the equator. All right.
I'm a little confused.
I would be confused too. Like, why is somebody just hanging out at the North Pole? Maybe they're a scientist doing research. I don't know.
Santa.
Is it Santa? Okay. And then we've got, the first thing I thought of was Dora the Explorer's cousin, Diego. So maybe Diego's hanging out down in Ecuador. Ecuador is a country in South America that's on the equator. So remember, motion is relative. Relative to what? In this case, we're talking about motion relative to the axis of the Earth. That imaginary line running right down through the center. Okay? Is our Santa Claus figure up there at the North Pole, is he moving?
No.
Yeah.
Yes.
It goes
What kind of motion relative to the axis is Santa Claus doing?
Spinning. Rotating.
Is he really going anywhere?
No.
No, he makes one rotation per day. How long is a day?
24 hours.
So we can say we have a 24-hour rotational period, yes?
Yeah.
Okay, good. I'm going to give you a formula. I think yesterday I suggested to you that you put somewhere in your notebook a page or maybe the back of a cover or something for formulas. Here's your formula for today. Speed is equal to distance divided by time. S for speed, D for distance, and T for time. Make sure I have that in the frame. There it is. Speed is equal to distance divided by time. Or distance over time. Or distance per whatever unit of time.
Wait, what is the S?
Speed. Speed. I'll write it out.
No, I knew what.
That's okay.
I knew what the S was. I couldn't tell if it was a 5. That's what I meant.
All right. Now, in our little story here about our two figures on our planet Earth, have I given you enough information to determine both of their speed relative to the axis?
No.
Yes.
Yes.
In fact, we already solved for Santa's speed. We said he's going nowhere. So all day long, he's not going anywhere. So his speed is 0. Okay? He's not going anywhere. He's moving nowhere. All he's doing.
Distance is 0 or no?
Yep, the distance he's traveled is 0. So if you take 0 divided by 24 is 0.
24.
Wait.
No, it's 0.
I have this.
Okay, all right. Shh. Now, when we can get a result for Diego.
Yeah.
So take your distance, plug it in for the top line, the numerator, and take your time and plug it in for time, and do the math. And see if you can figure out how fast, relative to the axis, is Diego actually traveling around the center of the Earth.
In 1 day.
In 1 day. What?
Never mind.
And when you get it, don't blurt it out. But everybody should be working this on their paper. Huh?
Do we divide
Okay,
this?
so you do.
Yes, this is a division problem. Distance divided by time.
Distance. What's the speed?
Are you doing it?
Yeah, I already got it.
So you got 24,000. I mean, I'll put it up here for you.
Yeah, I already know.
So you just do
I got it.
divided by 24, right?
Yes, and that was
It's not divided by 20. What? 24 hours.
Yeah, you divided by
How are you
24.
getting, would you get 100?
Oh, you're right.
10,000?
It's
Yeah.
not
10,000.
Awesome.
Four
times.
All right. Shh.
Yeah, I know.
Shh. You guys remember the trick about division? When you put it like this, if something's on the top and the bottom, they divide out. So what is 24 divided by 24? 1. So I can get rid of them and replace them with 1. Well, if I get rid of the 24s and I replace it with 1,
just 1,000.
It's 1,000. And check it out, guys.
1,000 hours.
1,000 miles. The line, the division line in a fraction means per. 1,000 miles per hour.
Bro, I'm at,
You see how easy the formula works?
Yeah.
Did we already do the distance from my house to work for the speed formula?
Yeah.
No? All right, let's do that.
1,000 miles.
All right.
1,000 miles per hour.
Can I get rid of this? Can I get rid
Yeah,
of this?
boom.
You both explode.
So Diego is whipping around the axis of the planet at 1,000 miles per hour. Does he feel any different than we do?
Yeah, he's gonna be like a little like.
His skin's gonna be ripping off his face.
No, because gravity is much more powerful than the centrifugal force. And the air, by the way, near ground level is moving along with him too, right?
So he's being pushed.
So relative to the environment around him, he doesn't feel like he's moving at all, even though he's actually going 1,000 miles relative to the axis.
You know when you're in a car by a semi and you're
All right, hold on.
and it feels like you're not
Hey,
moving.
teach him a moment, real quick.
Okay.
So we're starting to have some side conversations. If they're about this, that's fine. But he's trying to ask a question or make a comment. If he asks a question or makes a comment to me, are you all excluded from that conversation? No, please don't be. And I don't want you to talk over he or me, he or I. There we go. But you can still participate in a conversation just by listening. Yes. Okay. So you might hear something. You want to go.
Also, I don't understand how if you're actually going 1,000 miles per hour around, how would you feel?
You won't feel it because the centrifugal force, the outward force of that rotation, is minuscule. It's almost not measurable compared to the force of gravity holding you to the surface. When we talk about Newton's laws here in a little while, we'll have, so if you have a force this way and a force this way, if one is value of 10 and this is a value of 0.1, which one are you going to feel? You're going to feel this force. You won't even notice this force if it's that far out of proportion, right? And what we're talking about here between Diego and Santa or us halfway in between would be much more than this. It'd be barely measurable. Yes.
Does minuscule, does that mean tiny?
Yes. Okay. Cool. Let's do another speed one. Same type. I told you yesterday I live 14 miles. Are you okay? I told you I live 14 miles from school. I'm going to tell you right now how many minutes. Are you listening?
Yeah.
I'm going to tell you how many minutes I live from work, how many minutes it takes to get here. And you're going to have to find speed, but I want you to give it to me in miles per hour, not miles per minute. Okay?
Please stop.
Wait, what? Oh.
You don't need a calculator.
Put your calculator up.
You think I know something?
Do you need me to do this with you?
I just, a calculator is.
All right. Some of you should be able, most of you should be able to get this, all right? All of you should be able to get it. I'm going to give you like 20 Mississippis, and then I'll go over it with you, okay? Try it. Try it. Write it down. Try to work through it. I want speed in miles per hour.
What is
Keep
that?
thinking.
You're on the right track.
He's on the right track, but exactly. Get written down.
So,
All right, everybody, we're going to go through this together, all right? I've got one person that's sharing kind of their work with me. I could have walked around. I'm lazy. You got 0.7.
Yeah.
All right, so let's see how we got that. You're on the right track, but not quite, as Bella said. All right, so, and then you were like, wait, do I divide this one by this one? Like, no, follow the formula. Remember, a fraction tells you numerator divided by denominator. That's how you do it, right? So if I take 14, make sure I'm in the image here, 14 divided by 20. Can 20 go into 14?
No.
No, that's okay, but it can't. So we're going to put a decimal here, and I can even put a 0 there if I want, right? 0 point something is what our answer is going to be. But this is not a one-step problem. It's a two-step problem. So can 20 go into 140?
Yes.
How many times? 7. Because it's the same as 2 going into 14, right?
Yeah.
So 7, and it comes out evenly, does it not?
Wait, so what did we get wrong then if it's not?
Because you have it in miles per minute. I wanted the answer in miles per hour.
So we do it by 60.
Now, stop. Wait.
Wait.
Think about it. You think this is the answer. Does the answer make sense? If this were miles per hour, if this was the end, does it make sense that I was going just over a half a mile an hour in my car to work?
How fast is that?
A half a mile per hour?
Oh,
I'll show you.
Let off the brake.
I will
I
show
can
you.
walk faster than that.
0.7 miles per hour would be like this.
No, I feel like it's a type
I
of
walk fast.
Okay? We are in miles per minute. How many minutes are in an hour?
60. Ain't that us? I literally told you.
All right. What's 7 times 0?
0.
What's 7 times 6?
40.
And then I got my decimal. And now I have gone from miles per minute, I've multiplied it by 60 minutes in an hour. So now we're in miles per hour. That is my answer.
So you're driving 42 miles.
Ah! Somebody just said, what's your name? You said, you only drive 40. No, that's an average speed. So that means that.
Average speed's the speed limit.
No. All right, so you remember instantaneous versus average speed? All right, shh. In any one of the instants of those 20 minutes on my way to work, I might have been going 2, I might have been going 5, I might have been going 55. My average speed over those 20 minutes was 42 miles per hour. Make sense? Okay, what's up?
That's slow. So
Oh, I thought you had a question.
I'm a speeder.
Speeder? Am I a speeder? No. So most of my trip is on 2 or 4 lane highways. So I do 55, maybe 60. Sometimes I go up to 60.
Where do you live?